Hi everyone, welcome to today's tutorial. So in this tutorial we're going to discuss how how we can evaluate the limits as x is approaching either positive or negative infinity. So if you have not yet subscribed to the channel, click on the subscription button and also click on the notification button so that you don't miss out on on everything that I'm going to be posting. And if you are interested in joining the group where I post these videos, you can just contact me using any of these lines on the screen and then I'm going to help you. Okay, let's quickly move on. So this is the question. Okay, so we begin with the first question. Okay, so we have f of x being equal to 8x, and we have plus 9 x to the power 3 minus 11x to the power 5. Yeah, so when you look at this question, and then they're asking us to find the limit as the limit of f of x when x is approaching what? Negative infinity. So when you look at this expression, x to the power 5 is way much greater than 8x plus 9x to the power 3. Yeah, so we can consider this to be insignificant compared to this expression there. So this expression is just the same as having negative 11x to the power 5. So if we get rid of this part, or we consider this to be way much smaller than that, we can say this whole expression is just the same as having this part here alone. So now what happens if we replace or if we put a larger negative number where there's x squared, or rather where there's x to the power 5? You discover that the answer that you are going to get will be negative 11 and then multiplied by a larger number that is negative here, because we're talking about negative numbers. A larger number that is negative raised to the power 5, the answer will still be negative. So that negative times the negative that is with 11 here, it's going to give us a positive. So what that means is that whenever we replace any negative big number where there's x there, we're going to get positive, a positive number because of this negative in front of 11. Hence, this tells us to say the solution for this expression here is positive infinity, because there is no probability of us getting a negative number after replacing any negative larger number here where there's x to the power 5. So this is the solution for the first part. So we move on to the next expression there. So we have the limit of f of x as x approaches positive infinity. So this one is just the same as what we have done here. We do the same thing. So this is equivalent to so the whole expression here, like I explained here, I said this part is insignificant when we are comparing it to 11 x to the power 5, because you can see the difference that is between x to the power 3 and x to the power 5 is very big. Yeah, so this is just the same as finding the limit of this expression f of x. Okay, let me do this. Even here, the way I wrote it wasn't correct. Let me do this. So this is just the same as saying the limit as x approaches negative infinity of negative 11x. So this one is the one that is giving us positive infinity. So this one will also say the limit as x approaches what? Positive infinity of what? Of negative 11x to the power 5 So when we put any positive bigger number here, let's say positive 1 or 1 million or 1 billion, we put it here and raise it to the power 5. As long as the number there is positive, the positive number that you are going to get here multiplied by the negative number there means that every answer that you are going to get after replacing a positive number where there's x will still give you a negative number because of this negative that is in front of 11. Hence the solution here becomes negative infinity as the solution. All right, so we move on to the next question, which is f of x is equal to, we have 10x to the power 2, then we have plus x to the power 4 plus 6x minus 2. So when you look at all these numbers here, this part and this part, they are insignificant when we compare them to x to the power 4. So having the limit of, or finding the limit of f of x as x is approaching what? As x is approaching negative infinity is just the same as just finding the limit of x to the power 4 as x approaches what? Negative infinity. And this is going to give you what? When you replace any positive, any negative number where there's x here, because the power here is what's this? Because the power here is an even number, means that whether you put a negative or a positive number where there's x here, the answer will still be positive. Yes, the answer is going to be positive, and this implies that the solution for both cases, whether positive or negative infinity, will still give you what? Positive infinity. So I've actually even answered for the other part, which is when x is approaching positive infinity. This is just the same as finding the limit of x to the power 4 as x approaches what? Positive infinity. And this gives you what? The same positive infinity. The reason why in the first question here, the first part there, we had to get the negative infinity as a solution, rather positive infinity as a solution. When you look at x to the power 5, it was 11, negative 11, x to the power 5. This 5 was an odd number. So when you raise a negative number to an odd number, the solution is always a negative answer. So that negative answer times this negative is the one that gave us what? Positive. That's the reason why the first solution that we get, that we got when we replace negative infinity there, the answer was positive infinity. Yeah, I guess you've understood this part. All right, we move on to the other question. So we have that other question, which is f of x is equal to, this is a rational function, meaning it is a fraction. Yeah, it's a function that is in a fraction format. So we have 6x there, then divided by 7x to the power 3 plus 9. So now, if you have such a function, and then you've been asked to find the limit of this function as x is approaching either positive or negative infinity, this one is a bit straightforward. Yeah, because there's only one thing that you need to understand before we even begin to solve this one. So one thing you need to understand is that when you find the limit of any function that is in a rational form, let me say when you find the limit of any function that is in a form or in the format x to the power n, this n can be any positive integer. Yeah, this n can be any positive integer as x is approaching either positive or negative infinity. The solution for this expression is what? Is equal to 0. So if for instance we say the limit of x as x is approaching positive infinity of 1 over x to the power 2, the solution is what? Is 0. Oh, sorry. Yeah, it's 0. So this can be 2, 3, 4, 5, can be 1, 2, 3, 4, 5 going up. Yeah, so the solution will still be 0. So let us apply the same principle to solving that given question here. So finding the limit of f of x as x is approaching positive infinity. So I'll say plus or minus infinity. Okay, let me just do it bit by bit. So what we do is we say the limit as x is approaching positive infinity. So I'm going to divide the whole function by the highest power, or the x value with the highest degree or the highest power. So in this case, the highest power is what? Is x to the power 3. So I'm going to divide 10x to the power 3 by x to the power 3. We'll say 6x by x to the power 3. Everything divided by, we have 7x to the power 3 over x to the power 3 plus 9 over x to the power 3. So now when we do the division there, the solution will be the limit as x approaches positive infinity of this and that will cancel. We just have 10 there. Then we say minus. Then when this cancels with 1x there, we're going to remain with so minus 6 over x squared, and then everything divided by, divide this and that, you're going to get 7, divide 9 over that, you're going to get 9 over x to the power 3. So when you distribute the limit to each of these terms in the expression here, you're going to have something like this. When you distribute the limit, so the limit of 10 when x is approaching positive infinity will still be what? 10. So the limit of any constant when x is approaching any number is simply just that same constant. So now when you look at this expression here, the limit of 6 over x to the power 2 as x is approaching positive infinity is going to be like this. Yeah, it's going to be like this. What I'm trying to say is the limit of when we get this negative x, 6 to the power 3 as x is approaching what? Positive infinity. It's in this format. And hence, when you look at this is a fraction with x to the power 3 as a denominator. So, meaning this expression gives us a 0 as a solution. So, we say minus 0, and then everything divided by. Same applies to this one. This one is a constant there. So, the limit of 7 as x is approaching positive infinity will give you what? 7. The limit of this part, it's in this format. So, meaning that will also give you what? A 0. Hence, the solution is simply just 10 over 7. So this is the solution of that limit. We proceed to the next question. Before we proceed, let me mention this. So here, whether it's negative or positive infinity, as long as what you're dealing with is a rational function, the answer will still be the same. Because when you look at the answer will still be the same. Because this is what this statement states, and we follow the same steps, the same procedure here. You first divide by the x value with the highest degree of power. Yeah, so let's quickly move on to the next one. So the next one is this one here. We have f of x being equal to 12 plus x, everything divided by 3x squared minus 8x plus 23. So first thing, you divide everything by the number with the with the value of x which has the highest degree. So when you divide everything, we're going to get so say the limit of f of x as x approaches what? Positive or negative infinity will therefore be equal to when you divide 12 there by x to the power 2, because x to the power 2 is the one that is having the highest degree there. So we have x to the power 2, and then we have plus x over x to the power 2, and then divided by 3x squared over x squared plus minus 8x over x squared plus 23 over x squared. So when you do the division there, so here we're finding the limit. Okay, the limit as x is approaching what? Positive or minus infinity. So you do this. Once you do this, you discover that this part here is in the format that I wrote here, which is the limit as x approaching plus or minus infinity of 1 over x to the power n is equal to 0. So it's in this format. And what do you do? So this part gives you what? A 0. This part will also give you a 0, because when you simplify this, you're going to have 1 over x, which is still going to be in the same format there. So you have plus 0, everything over 3. This and that cancels. You remain with 3. So the limit as x is approaching positive or minus infinity of 3 will give you 3. Then you have minus 8 over x, which will also be in this format. That will also be a 0. This part is also 0. So this will give you 0 over 3, which is just 0. Okay, we'll proceed to the last part. So the last part, I'll do it step by step. So you do the same. Yeah, you do the same to find the limit of that question. So you divide the whole expression by the term with the highest power. So we have f of x is equal to 5x plus 7x to the power 4, everything divided by 4 minus x squared. So when you do the division there, you have something like this. Okay, so we say the limit of f of x as x approaches positive or minus infinity. Let me just do this. So I'm going to do the division. So I have 5x over, the highest power here is, the highest term there is x to the power 4. So over x to the power 4 plus 7x to the power 4 over x to the power 4. And then everything divided by 4 over x to the power 4 minus x squared over x to the power 4. Then you have sorry, okay, yeah, it's already done. I thought there is another term. Okay, so from there, when you do the simplifying, you have the limit of this and that. You have 5 over x to the power 3 plus 7, everything as x approaches what, plus or minus infinity. Even down there you have 4 over x to the power 4 minus x squared, and 1x squared will cancel, meaning you remain with 1 over x squared. So this part will give you a 0, this one a 7, this one, so this one is undefined. So now if you have such a case, what do you do? So when you've been asked to find such a limit, you use what is known as L'Hopital's rule. Yeah, so this one, you can say the limit does not exist, or it's indeterminate, but you use what is known as L'Hopital's rule to find this limit. So what do you do? Okay. Yeah, so meaning we are going to differentiate all the terms in this expression. So we're going to have something like this. I'm going to find the limit as x approaches positive or negative infinity of, when you differentiate 5x, you remain with 5. Differentiate, you differentiate 7x there. You differentiate 7x, 7x to the power 4. You're going to remain with that is 4 times 7, that's 28. X to the power 3. Everything over negative 2x. Because when you differentiate 4, you get a 0. So you just get a 0 there. You just write a 0 there. Okay. So after doing that, you can also try this. Try to plug in try to find the limit of this expression. If it fails, you because when you find the limit of this part, when you divide by x to the power 3, you still have a 0 as a denominator. And then if the denominator is 0, it means that the expression or the limit will still be indeterminate. So what do you do with such a case? You continue differentiating. So when you differentiate this part, discover that 5 will become a 0 there. So you're going to have something like this. The limit as x approaches plus or minus infinity. This part will be a 0. Then this part will be 28. Yeah, so that other part will be 28 times to be 28 times 3. That will give you something like 84. So you have 84x to be 84x squared over, when you differentiate this, you have negative 2. Yeah, so you are going to have negative 2 as the solution there, as a denominator. So you try also to find the solution for this. So negative 2 into 84. So negative 2 into 84, that will be negative 42. So you have negative 42x squared. So this is what you are going to get as the solution. So rather, this is not the final solution, but you find the limit of that. So this will be the limit as x approaches what? Positive or minus infinity. Okay, so the limit of this, so let's start with the one for positive infinity. I'll start with negative infinity. So if you put any negative number where there is a squared there, so I mean if you square any negative number, the answer will still be what? Negative. So if we start with the one for negative, yeah, I was taking both. I thought maybe to be the same case as the D and E, but in this case, let us try to separate them, but the answer will still be the same since the power that we have here is even. Meaning whether we put a positive or negative infinity there, the answer will still be the same. To still be, the answer will still be what? Negative infinity, because of this negative outside. Well, when you put a negative number with this x, the answer will be positive times negative, the answer will be negative. When you put a positive number with this x, the answer will be positive times negative, the answer will still be what? Negative. So whether you say plus or minus negative or positive infinity, the answer will still be negative infinity. Alright, so thank you very much for watching today's tutorial. If you have any questions, feel free to contact me using any of these lines on the screen, and then don't forget to subscribe to the channel and also click on the notification button so that you don't miss out the videos that I'm going to be posting. My name is Hamted. See you in the next tutorial video. Shalom, shalom.